All right, so we're doing some support. This is Math 321. I have no idea what day it is. We are going to start support for Chapter 9. Chapter 4, we did. We just finished Chapter 4's lectures. What we're doing today is 7.3 and 8.1 in the regular class. On Thursday, we're doing 8.2 and 8.3. Neither of those really have support. So we're getting a jump start on Chapter 9. Chapter 9 will be like the last section that we're doing math shit on. And we only have like a couple days of support for the math shit. After that, we're going to be using this hour to like go over stuff in math lab, and go over problems that we do in the regular class. So make it so understanding and homework is a bit easier and it's more directly applicable to what's going on in the main course, which is good because that's what your finals. All right. So in this section, we have compound inequalities. And these will be linear, so they're related to a line and stuff like that. And what the main two things we're gonna be working with here are intersection. Intersection goes with the word and they use this symbol. And then we'll be looking at union, which is or, and they use this symbol. We'll start with intersection, the and. Both need to be true. Both criteria need to be met. It's an and situation. So what I mean by that is we will solve for x, and we will have 3x plus 1 is greater than 4, and 2x minus 3 is less than 7. So we solve them separately. On this one, we subtract 1 from both sides, so we get 3x is greater than 3. Divide by 3, and we get x is greater than 1. Then we have an and. We solve over here. We add 3 to both sides, and we get 2x is less than 10. Divided by 2, and we get x is less than 5. Those criteria need to happen simultaneously. Both criteria need to be met. So it's best to look at this on a number line. We have infinity and negative infinity over here. So we've done this inequalities stuff before. X is greater than 1 means we put a circle on the 1, and we want values that are higher than it. X is less than 5, we put a circle on the 5, and we want values that are less than 5. When we say we want both, this is really like the overlap regions. The overlap happens between 1 and 5. Both lines are present here. The 1 is not included on x is greater than 1, and the 5 isn't included there. So we don't actually include the 1 and the 5, but we include every value in between them. So when we do interval notations, we use parentheses. Everyone ready for more? Kayla's not even paying attention. That's. Is everyone ready? All right, so the and or the intersection, we need both. Just keep that in mind. Let's try another one. And let me have you guys try this one. 2x plus 1 is greater than or equal to 5. And negative 3x plus 2 is less than 5. Give you one more minute, we'll do it together. All right. Anyone need lumber? Okay. Subtract 1 from both sides here, we get 2x greater than or equal to 4. Divided by 2, we get x is greater than or equal to 2. And we subtract here 2 here, we have negative 3x is less than 3. We divide by negative 3. And this changes the sign. We divide by a negative, we switch the sign. X is greater than negative 1. X is greater than 2 goes to the right. And since it's greater than or equal to, we fill it in. We include the 2. X is greater than negative 1 is here. It goes this way also. So the region of overlap is actually just the red line. It was the original one. That actually met everything. We would have 2 to infinity. What?
So like the line that you drew from like the negative 1 and it goes, right?
Mm-hmm.
Is because it's showing that x is greater.
Yes.
Okay.
Numbers greater than 1, negative 1 are like 0, 1, 2, 3. So we're pointing in the direction that where the numbers are greater than negative 1. Just so happens to be in the same direction this time. All right, let's give you another one. Maybe I better do another page. I'm writing kind of big here. Let's ramp the difficulty up as the homework isn't always necessarily nice. Give that one a try. You've learned how to do all these individually. We did this all, I don't know, from chapter 5, maybe? I don't know. 7. So clear the fraction if the fraction is stopping. Multiply through by the denominator. All right. We subtract 3 from both sides here. We get negative 8x is less than negative 8. Divide by negative 8. And we flip the sign, we get x is greater than 1. Here I'm actually going to subtract the 1 over first. And I get 2/3 x is less than 2. The slower way is multiplying by 3 and then dividing by 2. Or you can do them all at once. Multiply by 3/2. That makes the fraction on the left, the 2's cancel and the 3's cancel. This is like 2 over 1. 2's cancel here, and we get x is less than 3. So when we do it on a number line, greater than 1 is that way, less than 3 is that way. The overlap is between them. So we have 1 to 3. Another one for you. Give that a try. Anybody need longer? Right. Add 5 to both sides here, we get 3x is less than -3. Divide by 3, we get x is less than -1. And subtract 1 here, we get 2x is greater than 4. Divided by 2, we get x is greater than 2. X is less than -1 is numbers that are lower than it. And x is greater than 2 is numbers that are greater than it or larger than it. There's no overlap here. So there's no solution to this one. That was tricky, right?
The final should just be all of these.
What?
The final should just be a whole bunch of these problems.
No. You had to do math here. Final doesn't have any math on it. It's magic. Power of Hefe unleashed. How much math have you really had to do in this class? Not the 321 class, not the support class. But just the stuff on the homework that doesn't say support. Chapter 5 had you doing stuff on your calculator. But everything else, the computer did all the math. But you won't even need to do that. On the final, I will do all the computer work for you. It will be printed on the test, what the computer prints out. Your job is to interpret it. Still, you'll see, it's not that bad. As long as you're doing your homework. If you're not doing your homework, it's fucking harder than shit. You're not gonna get it at all. I have students every semester that make it all the way to the end. Stick around, never drop, don't do their homework the whole way, and just get crushed by the final. And it's just because they didn't bother to learn anything. They just kind of showed up. 5x plus 1 is less than or equal to 6. And 3x plus 2 is greater than or equal to 5. Fuck, everybody's either you guys are like, is everyone like getting this correct? You guys are fucking quick. Awesome. Divide by 5, we have x is less than or equal to 1. Divide by 3, x is greater than or equal to 1. X is less than or equal to 1, fills in the circle and points that way. X is greater than or equal to 1, fills in the circle and points that way. And the actual point of overlap is only x equals 1. I tried Takis for the first time this weekend. Why is that funny? I've never had them. I was at something and then we had a bunch of little mini bags and I fucking went, oh, I normally don't like super spicy shit. I'll have them on occasion, but like chips nowadays are like everything is fucking super spicy and that's like all they make anymore for shit. A lot of different chips and shit. I'm like, what the fuck? Whatever happened to like mild spicy? Whatever happened to just regular cheesy, like nacho cheese chips?
Did you
I liked them. I never wanted to try them because they always say like the chili, spicy chili with lime, and I don't like lime with my normally, but the lime is so mild, I don't even detect it. It might be because it's just so fucking hot, it's burning my fucking mouth. Do they have any flavor other than fuego?
Yeah, they have like 4 or 5 different flavors.
Okay. All I've ever seen is fuego. And I know that word, it means fire. It's in Italian for fire. Maybe Italian for Spanish for fire too, as far as I know. I don't know.
There's some that aren't hot, and then there's some that are like a mild flavor too.
I like what was really neat is I put several on my plate today. Went and bought a bag, put some on my plate. I only ended up eating like 8. Because I'm like, these are fucking hot. I don't need more. So like normally with chips, I'll fucking grub down on a fucking bunch of chips. Here, I'm fucking done after a few. I can actually have a diet version of chips with Takis. What the fuck is that all about? All right, let's kick it up a notch. Negative, well, not up a notch, but let's show another twist. So when the inequalities have the same thing, and they're set up like this, where one of them is there's a number less than it, and this is less than another number, we can actually merge this into one big, like triple inequality. Dun, dun, dun. And it makes it so you solve it all at once. Whatever you do to one region, you do to all regions. So when we subtract 1 here, we have to subtract 1 here, and we have to subtract 1 there as well. And when I divide by -4, I got to do it everywhere. And it will flip all of the inequalities. We will have 1 is greater than x, which is greater than -3.
How come you choose -4 to divide rather than 12?
What?
Because if it's on both sides.
I'm dividing by the thing in front of x.
Oh, I see what you're doing now.
I can see the confusion. Yeah, you thought I was picking the first one, but no. We're getting x by itself. Now, if you eliminate the x, this is still holds true. This says 1 is greater than -3. That's a true statement. I'm going to change it around though, and I'm going to make this -3 is less than x is less than 1. It's the same thing. But if you'll see why in just a second. This and set up like this, it actually makes a sandwich. This goes to like that. X is between them, so X will be between them on the number line. And if we do them in this order, they show up in the same order as the number line. So this is in the order of the number line. So it's easier to use. And when we write an interval notation, it's set up for interval notation. We start at -3 and we go up to 1. This is correct. Don't look at the top one and say 1, -3. That is bad. No. It would be wrong. So the interval notation has got to be in the correct order. You guys ready to try one? Nope, I see some people still writing. Slow your shit, Jones. All right. You guys try this and do the same approach. I know Fuego from a book series, Harry Dresden series. It's about a wizard for hire in Chicago. Takes place in the real world. It's good stuff. And he sucks at doing magic like illusion and shit, but he's good at blowing shit up. That's one of his spells. Fuego. Gurgle, gurgle. Oh, I hope the Takis don't come out that way. Actually, that doesn't hold true with gas. Like if you have some excessively spicy food, like it's too acidic. Like it will hurt to go to the bathroom. I know this is a gross topic, but it's true. But it doesn't have that same thing if you fart. You don't have like acidic farts. So like the acid just doesn't aerate, doesn't become a gas. Are you done already? What'd you get?
Well, I'm stuck. So I'm waiting for you to verify.
All right. Oh wait, you're not the only one. The other people still working. I said this was easy, and that's what you wanted on the final.
Well, I don't know if it's right or wrong. Just wanna like. keep an eye on it.
Ah. All right then, Michaela. Guide me. What did you do? Did you put them together first?
Yeah,
Now,
and subtract one.
so if you subtract one from each spot. Did you get that?
Yes,
Now what?
I divided by 3.
And you got,
3. Well, that's where I like stuck. What's like after that?
so what's the left side? What's -3 divided by 3? What's 3 divided by 3? So the negative just makes it -1.
You bring this down to. Oh, I see.
3's cancel out here, we got x there. 9 divided by 3 is 3 there. So we have -1 up to 3. And so in interval notation, we have -1 to 3. It's vitally important when you have this and scenario, the symbols must be the same. Less than for both of them is ideal, but you can always do greater than or greater than, but they gotta go. We can have A is less than X is less than B, or we can have A is greater than X is greater than B, but the symbols gotta be pointed in the same direction. Do not do A is greater than X is less than B. Because like if this is like, you should be able to, you should always be able to remove the X and one of the symbols. And it stays true.
Did you in a case that like. One is swapped, did you just not combine them?
You just would put them together like this. Exactly. This one, if I eliminate one of the X's and one of the symbols, I have -1 is less than 3. Here, if I try to do that same thing, do I say, which symbol do I eliminate? Do I say A is greater than B by eliminating that one? Or do I eliminate that one and I say A is less than B? I don't know what's going on here. If we look at this another way, this says X is less than A and X is less than B. We had something like that before. Here. They pointed in the same direction. So the overlap fucks things up. The overlap's a little different. We don't want to do sandwiches. When the symbols don't match. And let's see. We only got 2 minutes. We won't go through it, but I do want to point out something. All of the equations we did had the same symbol, but as long as the inequality portion is the same, we can have an equal sign on one of them and not the other. This is valid because the inequality is the same. And if you were to go through this, and divide by 4, we get 5/4, which is 1.25. It's less than x, it's less than 2. Less than or equal to 2. And we have one of those intervals that have a bracket on one side. All right, we'll do the union. We did this as intersection day. We'll do union on Wednesday. We'll call that a wrap.